Hi, I'm an old guy and I do maths. Now, we've already looked at the idea of domain and range in a previous video, and I thought that what I would do is I would take an example. Again, this is one that came from one of my students, um, and we'd work through it just to find the range of this function here. Um, Now, let's go to work. There are no restrictions on, no imposed restrictions on this function. It is, however, a quadratic, and that means that while it has an unrestricted domain, it can have any value of x inserted into it. There are limits on what the values of y would be. Now, this is in turning point form, which makes it really, really handy for us to work with. And the turning point of this thing is positive 1, positive 2. So it's there. Now, we're only interested in the range, so we're not interested in this value here. We'll just say that this point here is 1, 2. Okay, and that's the minimum point. So the range of this function is every number from 2 to positive infinity. The possible values of y for this function are from 2 to infinity. So the range can be written as square bracket 2 to positive infinity. I think you put a round bracket there. That's the range of this function. Right. Now what would happen if we played around with a restriction on the domain? So let's assume same function, 3, 1 minus x squared plus 2 equals 0, and we'll put a restriction on x. We'll make one of these equal to, what will we say? Let's make this negative 1, and we'll make this 4. Okay? Right. So what do you do in a circumstance like this? Well, it is possible to do this without graphing it, but we are going to graph the information that we've got. Now, we already know one or two things. We know the turning point of this thing, which is 1, 2. Now, what do we do next? Well, the next thing I would do is I would put this value into this equation. So, what do I get when I do that? Well, I get 3 into 1 minus negative 1 all squared plus 2. And that is equal to 1 minus negative 1 is 2. 2 squared is 4. 3 fours are 12, plus 2 is 14. So at negative 1, this thing is a way up here at 14. Okay. Now I've put a round open symbol here because of this symbol here. This approaches this value but does not reach it. Okay. Right. So let's put 4 into this. So that is 3 into 1 minus 4 all squared plus 2. this is going to go off the scale. You don't plan for these moments. Okay, 1 minus 4 is negative 3. Negative 3 squared is 9. 9 times 3 is 27, plus 2 is 29. And yes, we're going to go up here and off the scale. Apologies. And I'm going to put a solid dot there. And the reason for that is because we have an equals in here. So this point here, what did I say? 29. 9 3 is 27. Yeah, 29. So this point here is 429. This point here, if we actually attained it, would be negative 1, 14. Just get that written in there, not very neatly. Now, what is the range of this thing? Well, the range is from, in this case, the minimum y value to the maximum y value. So we can say that the range of this function with this restriction on it is from, what did we say, 2 to 29. And they both have square brackets because there's an equal sign in there. Now, if this thing had ended down here somewhere, this would be the greatest value here, and 14 would have a round bracket. Okay, sorry, it would have a round bracket. You didn't quite see that. So the range here is from 2 to 29. They're both represented by solid dots. The function actually equals these values, so therefore we have square brackets. Just to repeat, if it were 14 that were the highest point of this graph, which it is not, 14 would go in here and there would be a round bracket to represent that. Okay, thanks for watching. I hope this was helpful. See you later. Bye-bye.